show. We're distributors of like really large format printers, so stuff that will do billboards, vehicle wraps, and then 3D printers as well, which is kind of like the basis of what I'm here to talk to you about today. Have I got a clicker? Ah, thanks. So, I'm here to talk to you a little bit about the key to creating skills for the future. What is Industry 4.0? What impact that's going to have on our day-to-day lives, and what this means for you in the room, basically. So, a little bit of a history lesson to begin with. So, as you may know, the Industrial Revolution started around the 1780s, where we saw the movement from hand machines to powered machines using steam, basically. So it was an increase in production, which led to an increased population and also an increase in skill sets. This is going to be a trend going forward as well. Then we went to mass manufacturing, where we went from using steam as a source of energy to electricity. So again, it really ramped up production, ramped up manufacturing. New skill sets were needed again, and again we had a population boom in this period. In the 1970s, we saw the introduction of the IT and the internet, which caused a 365, 24/7 global economy. So people are always talking, always manufacturing. And again, this brought new skill sets and demand for new skill sets, which kind of leads us on to the future of manufacturing, which has been termed Industry 4.0. Now what this is basically like the introduction of cyber-physical systems into manufacturing, which ultimately means less human intervention, less waste, and more customization, which is really the kind of only sustainable way to continue manufacturing things as we do. So again, this means new skill sets. Right? So this was the trend I'm talking about. This just kind of highlights it. So when I mean cyber-physical systems, I'm talking about robots and software, for example, communicating with each other to produce a manufacturing line which would have traditionally be done by people and manpower. So when I first heard about this, I thought it was a load of waffle, to be honest. I was just like, this is just nebulous rubbish. But I've actually seen it now. I've seen it in action, and it makes sense. So one example of this is a company called Hoyer and a software company called Materialise, who have set up a scanning software. So you walk up to this kind of mirrored scanning station, and it scans your head. You know, fully maps out your head, all the contours of it, and it will produce a fully bespoke pair of glasses that are tailored for your head. And you can choose different designs, so like different style creations, and then it will again completely tailor them for you. And then you can get your custom lenses put in, where these glasses are then 3D printed in any colour, any style that you want. And the cost of producing one pair of glasses is the same as the comparative cost of producing 50,000 pairs of glasses. So what I mean by that is you don't have to produce loads of them to get economies of scale to make it affordable to produce one. You can just produce one, because it's the same cost per part, no matter how many you produce. There's also no wastage. So traditional manufacturing methods are very wasteful, and we also spend a lot of time shipping stuff around the world, whether that's raw materials or actual products, and it's just not a sustainable way to continue to produce stuff. So really this is the only, in the way I see it, the only viable way to continue to manufacture stuff. So again, another example is Echo shoes. So you can now get these fully customized 3D printed shoes where there's no waste, and it's the same cost to produce one as it is to produce 10,000. I saw another, I got really excited about it. I'm a bit excited because I'm a geek. But a few weeks ago I was in Germany at a trade show all about 3D printing, and there's a chap there with a foot scanner. So you take your shoes and socks off and step into this scanner, and it fully maps out your feet. So all the topology of it, your instep, pressure points, so where your feet are taking the most pain and pressure from when you've stood around and walking. And using this information, it has an algorithm that creates a lattice structure, right, which can be created on a sintering 3D printer, And it basically creates an absolute bespoke structure which is unique to you. The guy said that they're like snowflakes, there's not one that's the same anywhere in the world. And then they can 3D print these insoles based on this information that they've got from your foot. And they can do that, produce it and sell it to a customer for $150. And he said that the traditional way of doing that, they cost $600 for a pair, and there's only 4 designs. And depending on which kind of what your foot fits closest to is the design that you get. So it's not tailored, it's not bespoke for you, it's much more expensive, and there's waste involved in the process. So what this other company have done, have brought in a new method of manufacturing using Industry 4.0 that reduces waste. It's completely customizable, completely tailored for you. It's better for you. It's just better all round. Right? So again, all of these things makes me see that this is the way things are going. And here are some examples of big companies that are investing in this way of thinking, because ultimately, as I say, it's the only sustainable path forward. Some big names there, as you can see. So here's this just kind of reinforces that point. At the moment, products are manufactured, it's cost driven, right? So if you wanted to get 100,000 of these made, right, you'd send it to the place where labour is the cheapest, the cost of raw materials is the cheapest, and that usually involves a lot of carbon footprint from transporting goods around the world. What 3D printing means is you can source the raw materials for the goods locally, and the difference in price through region won't have as big an impact on the consumer good because of the process that it's manufactured, right? So a good example of this is HP's new 3D printer. The powder that they use in that is manufactured in Lancaster, so it's made in the UK, it's shipped locally, it's not shipped all around the world. And the idea is, the kind of end goal of this 4.0 is that you'll have centrally located manufacturing plants, right? And they'll have a variety of different robots and 3D printers and automated systems in there that when you want a product, rather than you clicking order and it has come from one of these big batches of tens of thousands of stuff made, shipped around the world, what you've ordered will get digitally sent to one of these manufacturing centres, and it will create it for you there and then, and it will then get shipped to you. So it will be created additively rather than subtractively, so there's no waste. There's less carbon impact in the actual raw materials that have produced that part to then get created and shipped to your door. So it's a bespoke, customizable, carbon footprint reducing way of manufacturing things. So that just kind of summarises that. But what this really means is there's needs another change in skill sets, as kind of highlighted through these original industrial revolutions, right? So what we need now is 3D natives and people with 3D skill sets that are just second nature to them, which starts with you guys in this room, right? Because that's going to be the students of today. So yeah, this is what it all means. Advanced digitization, the Internet of Things, integrated workflows, using additive manufacturing, 3D printing, it all comes down to having these skill sets in order to be able to actually roll this out and produce it. So this is a quote from the World Economic Forum. 65% of children entering primary school today will ultimately end up working in completely new job types that don't yet exist. You've also 47% of today's jobs will disappear in the next 25 years. Again, this highlights this real change in manufacturing, change in thinking. So this is a kind of typical classroom environment of today, where we see it going in the future as having more of these kind of maker spaces, right? So more design iteration, more computer-aided design, which all lends itself to this Industry 4.0 skill set. But when we're talking about these, particularly with 3D printing like this, people immediately think, oh, it's just for D&T. We've got some great examples here with us today that shows how you can integrate it across a wide different range of subject areas, because it's so versatile and it lends itself really well to classroom aids, or I mean, we've even got 3D printed braille with us, so you can learn braille using one of these 3D printers. But really, it's not all about the output, it's about getting to that point, which I'll talk about in a minute. But we've gone past the point of niche adoption with 3D printing now. It is becoming more of a widely accepted technology because people can see the sense and how this is going to be integrated into the future, particularly in manufacturing. But before we get to this full point of mass adoption, we need educators adoption, because that's where it's going to come to when the students of today are going into the market, right? So they'll be saying, for example, if they've learned a particular software on how to design something, they'll be looking to go and work for someone that's using that type of software. And with 3D and the way it's going, I genuinely believe it's going to be commonplace everywhere. So the sooner it gets adopted in education, it's better for the economy, better for the students. In 5 years, every school will have 3D printers. I mean, in Scotland, this is already the case. The Scottish government said that every single school in Scotland has got a 3D printer, which has now happened. So this ball is starting to roll. It lends itself to STEM really well. So we've got examples of like dissectable frogs with us that you can reuse, animal cells, we've got counterbalancing, we've got an Archimedes screw, so it takes into account history, physics, maths. What I'm trying to say is it's not just technology, that this 3D printing hub that we've brought with us today, it doesn't just suit the D&T teachers' needs, it can suit a lot of needs within education, particularly with classroom mates. A good example of that is, I was actually a student at the West Bridgeford Comprehensive, and I went back there recently because I became a STEM ambassador to kind of promote 3D printing into education, and I went back and did 3 lessons with the maths, year 8 maths class. So this was everyone like really engaged around the 3D printer. They all found it like really exciting. On the first lesson, I introduced 3D to them. I showed them the 3D printer and asked them about what they see 3D being used for in the future, which was quite interesting. And then we spoke about careers that may well have an impact on 3D for them in the future. So asking them what they wanted to do, and then figuring out how computer-aided design or 3D printing or additive manufacturing is going to impact what they want to do going forward. On the second lesson, the students were tasked to design a 3D phone holder, which all of them did within 50 minutes. One student did it within 2 minutes. He was like really, really bright. He'd been 3D modelling at home because he got into Minecraft, and that's all about 3D design. So he came back the next day for the final lesson and said, "Oh, I've designed this at home." And he'd basically gone home that evening and designed a phone holder from his own hand. So I printed it off for him, and this student was really like kind of overconfident, if you like. And the real good part of this is this phone holder didn't work, but I've got it with me, so you're welcome to come and see it on the stand. So I said, "Sam, look, really well done. This is an incredible design, but this shows the benefit of kind of design iteration and making sure that you get your product right before you go for manufacturing." Because I put my phone vertically in the phone holder and it fell over, and he just laughed and he says, "No, it does work." And he turned my phone sideways like that. It fit perfectly. So what it shows is that design iteration is a really important part of particularly product design or computer-aided design, because you rarely get it right the first time. So, but this was really fun, and all the students found it really engaging. So let's tick some boxes. So yeah, 3D printers today are what computers were in the 80s and 90s. So I remember when we first got computers into the school that I went to, and everyone was blown away by them, and there was like a limited time that you were allowed on the PC so everyone could use them, and we were using really basic kind of bridge building software to build a bridge over a ravine to then send a train over. Well, now you can 3D print the bridge, so you've got something physical to actually test, and then put loads on the bridge and test its structural integrity. So it's much more engaging, much more hands-on. And within that whole process, they're learning CAD skills, iterative design skills, coding skills. So it ticks lots of boxes for education, in my opinion. But what really counts, right? So there's lots of 3D printers out there, lots of companies saying, "Do buy this 3D printer, it's the best thing for the classroom, the best thing for teachers." The way I see it is that really it's an output device, right? It's like the 2D printer in the school. You don't ever calibrate it or put your head inside the printer or maintain it. You just expect it to work, right? It should be the same with a 3D printer. So what we've got showing in the exhibition hall today is basically a plug and play 3D printer that's very easy to use. You don't have to have a degree in 3D printing to be able to use this thing. Plug it in, turn it on, send prints to it, and it works. But alongside that, there's a load of resources that the company that have manufactured the 3D printer use and offer educators to help you integrate it into the classroom. So one of these is something called the Educator's Guidebook, and this is a step-by-step free resource that you can have. It has 10 classroom-ready lesson plans in there, and it tells you step-by-step how to create them and how to integrate it into the classroom. They've also made a website called Thingiverse. This website's got over 2 million files on it that you can download and print for free. But within that, there's an education section that's got over, I think there's over 400 lesson plans in there now, covering 9 key subject areas. And again, all of this is free, which is great, but really, the focus should be on the students designing and the students using 3D CAD software to learn these skills, these design iteration skills. All of this stuff is just to help you hit the ground running and to give you that confidence to then start building your own lesson plans and to start sharing them on this platform as other teachers have. So yeah, just to summarise that, why make it like them? Great printers, they're really easy to use, they're very reliable, and they've got loads of resources to help you integrate it into the classroom. So we've got one of these kind of racking systems with us today in the exhibition hall. I welcome you all to come and talk to myself and my colleague Les, who's just sat over there. And we'll show you some of the resources that we've brought with us and some examples of how it's been integrated into education. And yeah, I hope you come over and say hello. Thanks.